on last few days, not few days, even yesterday I was working over the layout of this LPDDR4, and just LPDDR4 routing took around 2.5 hours, right? So I mean, it will be like more time consuming in your case, because I've done that so many times, so I know how to place all these things on the top layer, and again, the thing is you have to do that, right? So yeah, but why I'm doing today's session, it is not that important, but yeah, it will just give you direction, like how you can start the layout if when you will be doing that by your own. Plus I've just recorded, these are all the layout and placement sessions that I've recorded. So till now it is around you can say 5 hours. Okay, so there will be like 5 hours more for block-wise connection. So till now I've routed all the high-speed tracks, and that I'll share later.
People who don't know which tool I'm using, it is Altium Designer 22.1, and if you wanted to get the free trial of that tool, I put link in the description. You have to just click there and register yourself. Within 24 hours you'll get the license. PDN Analyzer tool is a separate license from Altium Designer, so for that I have put a separate link. For purchasing PDN tool license, you have to click over that link. With that said, let's roll the intro.
Even inside the zip file, I'll share that today as well if you want. The thing is, I'm just planning these sessions, and it is kind of live recording. So when I'll be working on the board, I'll just turn on the recording and that's it. Like there will be no audio, right? So what I will do, I'll just dub all these because it is very important, right? Till schematic, things was not that complicated. We can able to do that live, but layout is kind of thing that it will take like hours, right? So that's why I thought this way. So it will be like very useful in your case. Apart from that, so as I told you, I've routed all the high-speed tracks. Okay. So today's we're just going to sum up everything in a very precise way. For example, firstly, okay, so our last session on the SI discussion, right? So there I told you I'm just going to share 2 project file with you. So that I will update today. So if you open that SI session, where it is, this one. Okay, so here I've added, see, this is shared by Robert Ferenek, right? So I've just added that as well. If you wanna do the SI and PI and TI on this one, you can do that as well. So it has, I already did so many times on this, but yeah, this is the IMX6 IBIS model, and this is the IBIS model of the memories that he used. Apart from that, this is the module schematic and project file, right? So this is open source project. You can download from his website as well. Apart from that, I've designed one BeagleBone board. Okay, so this is the schematic. It is not designed so professionally. This was the first board I designed, and you can see it's from 2020. Here you'll find all the models, right? So I've already did few simulation on the BeagleBone board, so you can delete those or just let it be like that. And these are all the models. So this is the model of the processor, which is AM3358, and this is the model of the eMMC chip that we will be using, right? And this is the model of the memory. Okay, so it has a lot of variants in memory. One is for I guess the earlier version of BeagleBone, right? So this is the latest version, which is V80A. That is for BeagleBone Black B3. Okay, so you have to assign this model on the memory. Okay, so you can do like eMMC simulation. You can do this thing DDR3 simulation between this one and this. Okay, so in this I've used DDR3 because this is the very not that wide range processor, right? So it's it's for small applications. Okay, so I'm just going to share these 2 files as well. So when you'll be watching the simulation videos on Hyper Linux, you can do the analysis on these two projects. Okay. These both are DDR3. Okay, so this is also DDR3 and this is also DDR3. Okay. Apart from that, I'm just going to demonstrate. So maybe you people already know about like how to do length match of any track. Okay, and in Altium, especially in Altium Designer 21, they have included few more features on length matching. So before there was like Sawtooth and this thing, the Serpentine, normal Serpentine, but they have integrated one more, which is Trombone. Okay, so I'm just going to introduce this as well, like what is the like how it is better than accordion, okay, or the normal Serpentine that we use to length match the track, and yeah, we'll discuss different tabs as well. This is one thing. Apart from that, blockwise layout. So blockwise layout is nothing, just I'll just show you. Okay, so this is a kind of step that I'm going to do from maybe I'll start it tonight, and yeah, after finishing this I'll go for power plane. So blockwise layout is nothing, just you have to pick one block and you have to just do the placement again, like that would be the final placement as per the layout. So for example, like we did for LPDDR4, right? So what we did, we just removed all these bypass capacitors, reference resistors, everything, right? Then later when we'll be placing it second time, we just planned everything accordingly. Like all the big capacitors should be placed like that. It is on the same layer. All the small capacitors which we need to place closer to the pads, right? It should be on the top layer and it will be like very close to the pad, right? So same thing we did for this one as well, right? So before fan out of RK3399, what we did, we just placed all the component, right, to verify, okay, we can able to do that or not, or which bypass capacitors we can't able to place, like for example, in case of let's suppose VDD CPU B, right? For big CPU, let's suppose we have like 2 or 3 extra number of component there, right? So what we did, we just masked those component, and whatever the number of component, we can able to route those easily, or we can able to place according, because it's a very dense placement, right? Everything is too close to each other and there is no scope to place any extra component. So whatever the number of component that we have planned, okay, and during the implementation, if it is like the quantity was higher, we removed those, right? So then we did the final placement and fan out. So the same thing we're going to do for block. For example, for PMIC, what we will do, we'll just select all the components from the PMIC, drag it outside, and then replace all those components. And that time we'll just keep thinking about the layout. For example, why I have placed this PMIC like this? Because this is the first pin, right? Its orientation can be in any direction, right? So the thing is, you can see VDDR is here, right? And where VDDR is going, it is going on all these pads, right? So we know that when we will be doing the the power plane sectioning, right? All this section of the power plane will be VCC DDR or VDD DDR, right? So that's how it is kind of planned, right? Similarly, like why I placed GPU here, if you will select that, hold on. Right, so why I placed all this GPU here? So the thing is, you can see the GPU power supply is coming in this section, right? Or we can place, if I mean, this place is again not final, right? Because we are using a separate buck converter for supplying the GPU, right? So it can be somewhere here or somewhere here that we can finalize. The thing is, our board size is really big as compared to the original board size. So like we have lot of scope to place all these components. Okay, so this is all we'll discuss during the blockwise layout. And let's see, the another thing is we're going to discuss the power plane planning. Okay, so again, power plane planning is not kind of fixed, right? Because see, till here our component placement is not fixed, right? That will be fixed after the blockwise layout. Okay, So according to that, our power plant planning can vary, right? But for SOC, because SOC is kind of fixed, this position is logged. We have routed these LPDDR4 for both of the SDRAM, right? So for these, this we can plan the power plane. Okay, so I will show you how we can section that and what will be the clearance between it. Okay. Apart from that, okay, I'll again close that. Hold on. Okay. Okay, then I'm going to tell you the review process as well. So review process is what, like, for example, I have routed these LPDDR4. Okay, so again, I know that by myself, but you can also tell me that this kind of layout or whatever the layout we did at the beginning, it's not like best layout, right? So that means there is always a chance of improvisation, right? So what we do during the review process, we verify a lot of things, right? So review process basically starts from the requirement sheet, whatever the requirement sheet is, then verify the schematic design, right? So all the nets are connected properly. We'll just go through each and every net, right? And we'll navigate through those nets and we'll verify, okay, our schematic is fine. After schematic, like there's a lot of other step, right? So I'm just going to note down those really quickly. And yeah, it's a normal process that we generally use on any design review, right? And again, this review process will never, it's a like you can say there can be any number of loop, right? Until the design will follow the each and every criteria. For example, schematic should be completely, there should be zero scope of errors, or you can say any type of error, right? Things should be connected properly. All the components should be connected properly. All the BOM information should be correct on the schematic, right? So just after the schematic design, we basically go for the BOM generation and forward that to, you know, the team which is, you know, going to procure all these components. You're getting it? So again, this is the whole process, right? So BOM should be correct. Manufacturing part number should be correct, right? In terms of PCB design, we basically check design rules as well, as I mentioned, because for example, for layout purpose, because I am doing the layout, let's suppose I am doing the layout and I saw something which is throwing some error, right? Just to hide that error, what I can do, I can just create some false design rule, right? And again, this is just, you know, it's just helpful for designer. But when we're going to manufacture the PCB, when we're going to test it, there will be like huge scope of problems, right? Because we bypass something. It can create short circuit. It can create lot of SI issues, right? So I hope you're getting my point. So that's why when reviewer you know, review the whole project, schematic design or PCB file, he or she need to review the design rules as well, right? What are the priorities of the design rules? Designer implemented those correctly or not? You're getting it? Okay. Another step can be how you have routed the connections. Okay. So again, see, if one person is working over the whole project, right, there will be a time when you'll kind of you know, saturate by designing this, right? You can't able to see the mistakes on the layout or for example on these tracks, right? So is this a perfect way to place all these connections like this, right? Or for example, we really need 3 layers to route these connections, for example layer 1, layer 2 and layer 3, right? Can't we route this connection something like that so we can able to use the same layer for routing the other byte group, right? So these all things we basically you know, it is the responsibility of the reviewer, and he need to figure out what are the mistakes that designer made during the design. Okay. Apart from that, yeah, so this is a kind of thing that we're going to discuss in very detail. So again, today's session is again kind of discussion based. And yeah, and these are the two assignments that I'm going to share today. So these are nothing, just you have to do the blockwise layout and length matching, okay, and the sectioning of the plane. Okay, so assignment 13 is nothing. Assignment 13 is about what are the other connections left. For example, I2C, UART, GPIOs, interrupt, right? So you have to route all those connections, because on those connections we don't have any such limitations as high-speed design, high-speed connections, right? So that would be kind of easy. So that's our assignment number 13. Okay. So again, I'll complete these assignment as well, and probably by 10th of June or before that, I will update all those assignment solution, or you can say some reference videos that I will upload on the website. Hold on. All right. So yeah, we can start from length matching. So again, you can also find these length matching tutorials on my channel as well. I guess I did that for differential pair before, but yeah, that was for earlier version of Altium. So let me demonstrate it quickly, then we can move further. So for demonstration, I'm just going to create a new PCB, and there I'll do that. All right. So anybody like already did the length matching for some high-speed tracks before? Like when we'll be working on some, modules, or there maybe it required length match. Okay. So let's do that quickly. So I'm just going to route a simple normal connections. Okay. So this is just simple route. Okay. Let's suppose I have to length match this thing. Okay. So for length matching, we just use this tab, and here we have two options, which is for single-ended and differential, right? So let's suppose I've selected this single-ended for now. Okay. When I'll press the tab or in the properties section, you'll see all these three options. Okay. So these two options, the accordion, or whatever you call the Serpentine, and Sawtooth, it's like from very first version of Altium, right? It's there, I guess, from 2017 or before that, right? So they just included this new option, which is Trombone, and let's start with the accordion. So here you will see lot of tabs, right? Lot of you can say there we have to fill the information. So this, as it suggests, right, this is the maximum amplitude of the Serpentine, right? And they have marked that as well. So I don't think like a lot of explanation required here. And this is the size of the step. So the step size is like when you'll so there are two ways to place the Serpentine. Okay. One is hold on. Okay. One is either you can do that like this. Like here you have to enter the information, and when you will start placing that. Okay. So this width or this amplitude will be 20 mil, because we filled that information here, right? Another way is you can adjust that manually. Okay. So one way is you know that what amplitude is required, okay, and just press the tab and fill that amplitude there, okay, or you can do that manually, right? So I always prefer manual option, because sometimes, because the space is fixed, right? And we will see that I'll just do few length match for LPDDR, but yeah, manual is, I guess, good option. Okay. So this the adjustment, the manual adjustment that we do, okay, that is the step size. Okay. And what is that step size right now? It is 3 mil. Okay. You can find that if you required, you can go for 1 mil if you have to exact length match the track. Apart from that, here we fill the information which is the target. Okay. So we have to fill, so there are like 2 or 3 ways to fill that information. I always go for manual, and it's a kind, see why we are going for manual, because it is keep varying, right, during the layout. Let's suppose you did some little bit adjustment and the target length will change, right? So here we enter the target length, whatever the target length is, and when we'll do the length match, it will just show you that green marker. You're getting it. So right now target length is just garbage value, but I'll show that later. Okay. Apart from that, okay, space is, you can vary that. So what you have to do, you have to just select it and you can vary the space. Okay. Now the question is, what should be the space between these two? Because see, during the discussion of SI, I told you lot of principles, right? So there was 6 principle of signal integrity. What was the second one? The second principle was signal is dynamic, right? So that means signal is traveling from here and here and here and like that, right? So that means whatever the signal is here, at the same time there can be different voltage here, right? So there can be chances of the interfere on the same line. You're getting it? Because these are nothing, just the 2 parallel connections going in opposite direction, right? So again, you can recall that impedance table, right? And here we know that here we have all the information. Let's suppose for this LPDDR4 SDRAM, we know that the clearance between the same byte group or other byte group, it should be greater than 2 times, right? So this difference will be minimum of that value, 2 times of the width of the track. Either it will be 3W as per the whatever the information given for each interfaces. Okay, so according to that we'll fill that information between the space. Okay, and we can also kind of vary that, so that step, so you can see that, right? So it is varying with 3 mil of step. If I'll reduce that, it will be 15. If I'll increase it, it is 18, right? So that is the purpose of this step. You can vary that 1 mil of resolution. You can, this is a resolution you can say, right? Another is meter. So meter is nothing, you just increase or decrease the sharpness of this one edges, right? You can see that, right? So it will be like perfect rectangular, or you can say, right? So there will be sharp 90-degree corner. So again, that is a kind of consideration, like when we'll have sharp edges on high-speed tracks, the impedance of the track will vary. Okay, so that's why vary, or you can say it increased. The impedance of the track increased slightly, right? So again, we don't want to add any discontinuity on the impedance side. So we'll always go for we'll always go for minimum 15 to or you can go for round option as well. So for round you can select from here and it will be like selected. So for round these two will be fixed 30%, right? This is a kind of rounded serpentine we generally use because I mean, not a specific reason of using it. Another thing is like it's a very fine and whatever the consideration was related to impedance. So according to that, this would be the perfect option, right? But one more disadvantage is if we're going to use this round option, so it takes like a lot of area to route the connection, because it's a like semicircle on the you can say the edges, you can say, right? So it takes a lot of space. So when you have to length match, you need a lot of area for routing these kind of serpentine. You're getting it? Okay, let's talk about another one. So trombone is nothing, just this kind of shape, and here we have like not that much options. So it has just radius and step. Step is the same thing that I told you. So radius is this one. So you can say this radius and this radius will be same. Okay, so whatever the total radius, or you can say 2 times of the radius, will go from here, from this point, because this is one end and this is another end, right? So that will be the length of this section, right? So it is like everything is related to this radius, so that's why you will not see any other options. And from here you can also switch between these metered and rounded. Okay, you'll get one more option, that is single side. I guess it's available for, okay, it's not available for accordion, but that means this will be at the single side, or this can be at both of the side as well. Okay, so let me demonstrate that as well. Okay, hold on. So you have to just click and drag, okay, like this. So right now it is selected single sided. If I double click on this one, and if I'll remove it, you can say it's like both side of the this is the center line, right? So this is both side of the center line. That depends, like where you have more space when you are doing the length match. The major advantage of doing this is, if you'll say lengthwise, like which one contains more length, it would be like almost similar. There can be like small difference of you can say 2 or 4 mm. Okay, so very small, minute difference. But another advantage is the gap between these lines, or because these kind of clearance can create issue, right? So using that, we can increase the gap between these lines a lot, okay, as compared to the previous one. So if I'll do for single side, let me do that above. Okay, so you can see height is almost same, right? And if I'll select, you can see length is so this is 683 mm, right? Let me make it little bit wider, so this would be like, okay, it's like that. Okay, so I guess we are using the same cross section. So its length is around 1126 mil, okay, and for this it is 1003 mil, right? So this is like almost same, but from clearance point of view, you can see there's a like huge clearance between those. So here we are using the clearances 18, and here we have 30. It's like almost twice, right? So that is the advantage of using the trombone. But yeah, during the layout, you have to see like which one is best fit as per our requirement, and according to that you can use. Okay, let's see the third option. Third option is kind of no one used that. I mean, I never used third option before, so let me tell you that as well. So Sawtooth, here you have like angle information. This is the tooth width. The tooth width is this one, right? And this is the minimum joint between two tooths, and this is the height of the tooth. That's it. And this is the maximum allowed height. So again, and you can also change that to single side or fixed size, whatever. So you can fix the size and just drag it whatever until the length will be matched, right? So let me demonstrate that as well. It's like that. So you can say there will be like huge sharp edges, and if I'm going to increase the tooth width, you can say that it will be like going to the similar type of you can say serpentine. There is a one type of serpentine, right? And when you keep increasing the tooth width until this and this will be equal, right? So it will be like the same the accordion type, one type of accordion, right? So this is also an option that you can use. Maybe there will be some specific application for using the Sawtooth, but in case of high speed design or whatever the high frequency tracks we use, we rarely use this Sawtooth option. Okay, so this is the thing I just wanted to tell you about length match. Let me demonstrate that quickly.